So let's do an example using domain and range. We'll do another one here. So we have a function here, f of x, and it's defined as x minus 4, all that squared, minus 3. If you know about functions and transformations, you can see that it starts off as an x squared graph, which is a parabola opening upwards. This minus 3 means it's been shifted down, and this minus 4 means it's been shifted to the right by 4. But that's not so important. What's important is being able to understand the question here. It says, what is f of 2? And finally, what's the domain and what's the range? I think it would help to graph it. I want to show you first of all how we can actually do this without graphing, this first part at least. We can do that. So what's f of 2? Remember the rule? It just says whenever you see an x, you replace it with 2. So for example here, we could say that f of 2 equals, let's see here, it's 2 minus 4, all that squared, minus 3. Let's see now, in the brackets, we have to do that first. 2 minus 4 is negative 2. Then we have to square that, subtract 3. But what's minus 2 squared? That's minus 2 times minus 2, which gives you plus 4. So it's 4 minus 3, which should be 1. Let's see if it works here. So what I'm going to do now is I'm going to try to graph this graph in order to see what the domain and the range should be. So I'm going to open up my calculator, open up a new graph, maybe just to be safe. Here we go. And we'll call it, let's see here, open bracket, x minus 4. And from there, square that. And from there, subtract 3. Go. Yep, it's been moved to the right by 4 and down by 3. Super. So what does this tell us? Well, how can we actually find out what value when x equals 2? I just want to show you a nice little trick here. Did you know you can do menu, you can do trace? Now watch this. This is really cool. As you just type in, of course you can use the arrows to actually move along, but I prefer to actually just type in the number you want. I just type in 2. You notice it goes x equals 2, I press enter. And it tells me that at x equals 2, y equals 1. Hey, look at that. So when x is 2, y is 1. Do you see how easy this is? I could do x equals 3, y is negative 2, x equals 4. You just type in whatever number you want and it tells you, if I want to like minus 5, it tells me that that's at plus 78, for example. And at plus 10, it'll be a giant number, right? Because it'll be like 100 minus, it'll be just under 100, I bet. Oh, well, that wasn't so much under 100, I guess. But anyway, so this sort of idea, if I did like 14, for example, there we go. That's what I was thinking. So you can do it anywhere, which I think is really cool. Now, the reason why this is really nice, here, let me go back to menu and I'll go back to a window. That's nice. I'll do zoom standard. I like that one. That's like the nice minus 10 to 10, minus 10 to 10 roughly. So if you look over here, where does it look like it's defined? You see, like if we want the domain means as we scan from left to right, is there a problem finding the function? Remember, that's a domain. Domain is all about the x's. So if we look at this, if I had x equals like minus 10, can you see how I could find my function? It would just be way, way up high here. And if I had x equals plus 10, I would have no problem. So just imagine, as I scan from left to right, or sorry, for you it should be like this. So from left to right, there's no problems finding my x, no matter where I define it. If I do x equals minus 5,000, I can still put minus 5,000, subtract 4 from it, square that, minus 3. I'll get an answer. It'll be huge, but I'll get an answer. And as I scan from left to right, I'll be able to find my function, no problem. So that means, how do we write no problem? Do you remember how we do that? The domain, I'll do it in a different color maybe. The domain then is going to be just, there's no problems with the x's. So how do we write that? We say x is an element of real numbers. Just means it can be anything you like. But the range, however, is not going to be that. Let's see what the range is. The range is as I scan from bottom to top. Remember doing a little imaginary line here? As I go from bottom to top, let's see what happens. From the bottom, can I find my function down here? Is there anywhere if I've got some vertical line down here, as I bring it down like this, can I find my function here? No. It doesn't matter how far I go to the left or to the right, I won't find it. So it's not defined everywhere. However, it starts being defined at exactly at minus 3. At y equals minus 3 here, I start to find it. So how do we say that? Well, we can say I start finding it at negative 3 and higher. Do you notice anything higher than that, I can find it. So how do we write has to be bigger than minus 3? Then we say like this. Y has to be bigger than or equal to negative 3. This is how we can do domain and range. Now these take some practice, okay? So I really do suggest you practice as many of these as you can, but this is how we do them. Let's see now if we can review linear functions, like this to infinity and beyond. False, you can't go beyond infinity. That's from The Office, the American version at least. Linear functions, they're just like linear graphs, okay? There's no difference for that, so we don't have to talk about it for much because we've done other videos on this. It looks just like this equation, you know, y equals mx plus c. It's just that. The only difference is we've got an f of x instead. So what? And the good news is, this is super easy. Hopefully you'll see that this right here is still the gradient. This is still the y-intercept. Okay, that hasn't changed. It's still a straight line. So there we go. Remember the gradient equation? You can look it up, right? But gradient is always y2 minus y1 over x2 minus x1. This is your equation for the gradient. Don't forget that. Because this still works. You can still find that little m. That's still the gradient, no matter how you look at it. So let's see if we can do an example. A sneakier one, maybe. So we have a line. It's called L1. Maybe I'll draw it then. I'll say, all right, fine. That's called L1. And it looks like the following. There it is. We got this O, we got a B, we got an A. And we're not told the numbers, though. Uh-oh. We're told that segment OB is 2 times the length of segment OA. What does that mean? Here to here is twice the distance as here to here. All right? Find the gradient. This becomes a little bit tougher seeming, but if you assign values to it, it's not so bad. If this one here is twice as long, I can make it 1 and 2. These could have been any numbers, but it turns out that'll be fine. This right here would be -1. Because this right here would be twice as long as that. Keep in mind, I could have made this 10, then this would have been 5. I could have made this 100, then this is 50 then. But it turns out the gradient will be the same. Because how do we find the gradient again? The gradient, remember we use this equation. Gradient is y2 minus y1 over x2 minus x1. All right, fine. Some people like to call that delta y over delta x. Whoops, I should probably clean up my... This looks like an x. Oh, no. What have I done? There we go. I'm just going to try to make it more obvious then. This is delta y over delta x. So what can we do here? We can look at this then and say, all right, well, from here to here, you see this point right here? This is my delta y. This right here is my delta x. I could have defined it also as y2 minus y1, but can you see that you have to go to the right by 2 units, so my delta x will be 2. And to get from here to here, you have to go up by 1 unit, so I put in a 1. Therefore, actually, I could say m equals 1 over 2. That's nice. I've answered this. My gradient is 1 over 2. Now it says, given that f of 4 equals 1, find an equation in this form. This just means find me a linear equation. All right. Well, let's try it out here. I'll do it in a different color. I need this equation. Instead of looking like y, I'm going to replace that with f of x. That's just like a y, though, so don't worry about it, okay? F of x equals, and we put in our m. We know m. M is 1/2. We still don't know c. We don't know the y-intercept. Well, it turns out we do. Can you see it from the graph? We can see the y-intercept right away is -1. But we're not necessarily sure, because this could have been -50. It could have been whatever. So it's a good idea to double check. So look at this information right here that they gave you. Look at this. They told you that f of -4 equals 1. What does that really mean? That means that when x equals 4, that means that y is 1. So this is really nice. What this means is that you can actually put this in, watch. If I had it in this form, y equals 1/2 x plus c, then wherever I see a y, I put in 1. So I put in a 1 here, equals 1/2. I put in x equals 4 here. The reason is that we can use this to solve for c. This is supposed to be a 2 here. So what do I get? I get 1 equals 2 over 4, which is 2 plus c. I want to get c by itself, so I move this over. So I get 1 minus 2 equals c. Therefore, c equals -1. Why is this important? Because now I can put it all together. Maybe I'll put it in red here. So finally then, f of x equals m, which is 1/2, times x, plus c, which is -1. Whoops, I don't have to say plus then, huh? In this case right here, it's a plus -1. I can just say this. This is my answer. And you see, you could have gotten it directly from this graph. We happened to be lucky by guessing 1 and 2 and then -1. We actually got this value right here. But this could have been anything, right? So you always use your equation. So what can we learn from this? First of all, don't get tripped up by function notation. This just means f of x just means y. Okay, so you just kind of convert it back. So f of x and y, see them as the same thing. In this kind of example here, you first use your gradient equation to find the gradient, and then you put it into the linear graph. In other words, you put it into this linear equation right here to find c. Do you notice that? That was the goal. We had to find c. Okay, we needed c, because now c comes up to here. That's c. There it is. So this is sort of how we did it. And I hope you can see, haha, that these aren't so bad, these linear functions, right? And we've gone back, we've also done domain and range. I hope that'll make some sense to you. It can be a little bit wacky, so it does take some practice to wrap your brain around domain and range especially. But hopefully the linear graphs are somewhat familiar with you since you've already done those before.